Welcome, everyone. We are grateful for you to join us today on this lovely Valentine's Day. And this is Built Green's webinar, Low Hanging Fruit, Practical Material Swap Outs for Low Carbon Construction. So if that's the webinar you are planning to attend today, you are in the right place. If you were not planning to attend, welcome anyway, and hope you enjoy the content. We will be getting started in a couple minutes, just letting people join the room right now, and we'll get started shortly. All right, we'll just go over a couple things to get started today. We will be having our Q&A at the end, but if you have any burning questions that you need to enter that into the chat, or if you just need a place to hold them so you don't forget until later, you are welcome to use the chat function. You are muted to start. We invite you during the Q&A to turn on your videos and mics at that time to participate in the Q&A. Should you have any technical issues, in the chat, there are posted some helpful tips and resources for you. Jane will be monitoring the chat throughout the conversation, and I am Sonia with Built Green. Welcome to our webinar, and we are going to be talking about low carbon construction material swap outs, and we will get started. Thanks for joining us. So just to give you some context of why you might be here, Built Green, in their 2021 updates to their new construction checklists, introduced embodied carbon in a very forthright way. We reevaluated all of our material efficiency credits, and the points in those credits were really reevaluated for their life cycle carbon emissions, including embodied carbon. And beyond that, we also introduced brand new credits specifically targeting embodied carbon. You can now, through your Built Green certification, earn points to calculate the embodied carbon on your projects, as well as calculate the embodied carbon and demonstrate at least 10% reduction for additional points. This is in addition to all the operational carbon credits that we are giving related to energy efficiency. And throughout this webinar, if you're not quite sure what embodied carbon is, I know Jacob will touch on that lightly, so don't worry if you don't understand that concept right now. Single family house size matrix was also updated so that any larger homes, instead of having to do extra energy efficiency, we actually switched that to a more embodied carbon perspective and material perspective. And so any homes that are larger than average based on their square footage and bedrooms will need to select either a performance or a prescriptive pathway to do additional material criteria. The performance way is to actually model and calculate the carbon, the embodied carbon, and demonstrate at least a 10% reduction. Or you can prescriptively earn additional material credit points over the minimum required for the star level that you're aiming to achieve. And this is both for our multifamily and our single family new construction checklists for projects permitted under the 2018 Washington State Energy Code that are required to use the 2021 checklist. So what does that look like in terms of maybe the point structure and the different star levels? So the embodied carbon requirements per star level, the requirements related to the concept of embodied carbon is that at 3-star, the only requirement is really the house size matrix to conform to that, as well as the material points. Now, to back up, to calculate embodied carbon, we really wanted to incentivize that practice. And so we're giving, just to calculate the embodied carbon, regardless of what that calculation ends up being, you will get 20 points for that. And as you can see in this table, for a 3-star project, that's nearly half of the required, that's half of the required material points for that star level. that are required. For single family, for multifamily, it's just under half because they are required to get 40 points and 50 points respectively. At 4-star, they need to use at least one material with a health product declaration or an HPD, or an environmental product declaration, which is an EPD, as well as conform to the house size matrix. In multifamily, they'll use at least one material that has an HPD or EPD, and both respectively need a material minimum of 60 points. So again, 20 points out of 60 is a pretty significant amount. To calculate embodied carbon, you will generally be using more carbon conscious materials, and so you'll also earn additional points through the process of using them in other parts of the material efficiency credits as well. So it starts to really build momentum in your checklist to, go through this process. Additionally, if you're reducing or required to reduce, you'll earn 30 points from that act. So if you're reducing the embodied carbon, so you're calculating it and showing a reduction of at least 10%, you're going to achieve 30 points for embodied carbon credits. So again, we're trying to put a lot of points behind this because we want projects to start doing it and really looking at how it can benefit their construction practices. So in 5-star, they are required to calculate embodied carbon, as well as use a minimum of 10 materials with salvage or recycled content, as well as the house size matrix in single family construction. In multifamily construction, they are required to calculate the embodied carbon. And again, 100 points and 90 points respectively are required to achieve 5-star in the materials section. For Emerald Star, this is an update forthcoming. Should your project be seeking Emerald Star, please contact us. It's a much more involved process, but we are currently considering to not only to match the new construction checklist, but for that to require not only calculating embodied carbon, but demonstrate at least a 20% reduction. There are no material point minimums in this category because Emerald Star is not a point-based system. It is more of a performance and prescriptive list of required actions. And so that's why we say it's a much more involved process. So please contact us should you be interested in Emerald Star. So some of the materials that Jacob, who will be speaking in a minute, will be going over are available here locally. So we do have local supplied materials that do meet low carbon criteria. We have salvage architectural projects, cork products, thermally modified wood projects, wool and hemp materials, a crushed oyster shell pavement that is locally sourced here in the Puget Sound, made with crushed oysters, and it's permeable if you're looking for a permeable pavement option. We do have local ready mix suppliers who can provide concrete with supplementary cementitious materials that will lower the carbon of that concrete. We also have locally sourced or certified wood products, bamboo, cellulose insulation. Some of these are products you're already using on your sites and may be familiar with, such as recycled content fiberglass insulation. Acre is a rice hull composite. We have micro cement, which is a more lower carbon eco-friendly cement product. We have recycled content gypsum, which I know some of our built green builders are already using. Wool carpet, linoleum, compressed paper composites, which is the generic form for what people know as paper stone or Richlite. We also have more US-based materials, which would be shipped in, which is hemp wood, wood fiberboard insulation, and hempcrete blocks. Those are all things that are currently available on the market, and some of these are very readily available. Some of the vendors that you have access to, Sedeco, Craftex, Green Home Solutions, your local ready mix facilities, If you talk to them about their mixed designs for their concrete, locally owned lumber suppliers, the Northwest Building Salvage Network really gives a good list of all our salvage architectural vendors, Shelfscapes, Small Planet Supply, Sustainable Wood Northwest, and Sankofa. On a more US kind of Canada vendors, 475 High Performance Building Materials, DeVita Hemp Block, and Hempitude, sorry, I'm probably mispronouncing that. Hemp Texture, there we go, I think. Many of these vendors are also Built Green members and will earn additional points for utilizing them on top of your material points, particularly in the equity and social justice section. So those are some needed points you may be needing in a different section as well. So these are local vendors that you have access to right now who can supply some of those materials that you'll see today. And with that, I'm going to hand it over to Jacob. And Jacob Racusin is the Embodied Carbon Analyst and Beam Trainer with Builders for Climate Action. And take it away.
All right. Thank you so much. Let me get my screen share going here. All right. Can all see my screen? Great. Well, thank you so much. It's an honor and a pleasure to be with you all today. I'm really excited to talk about some good solutions for getting the carbon impact and climate impact of our buildings reduced by looking at materials. So yeah, I'm with Builders for Climate Action. My background initially in the beginning of my career was as a builder, particularly a straw bale builder. So I kind of come from the dark green side of the construction industry. And that was back in right around the year 2000. And have since throughout the last 20 some odd years gone from the build side over to the design side. I do a lot of consulting and education and research on climate just building solutions, as well as continuing to work within my other day job is as the Director of Building Science and Sustainability for New Frameworks, which is a design build company out here in Vermont, which is where I'm beaming in from to chat with you all. All right, so enough about me. Let's get into the content here. I'm going to start with some basic sort of definitions of terms, frame the conversation a bit, some basic context, and then really start getting into some of the details around how to quickly and easily start bringing down our material carbon loading with some basic material swaps. All right, so for a really long time, and by a really long time, I would say since the 70s, our industry has been doing a pretty honest job, especially those of us in the more green or energy efficiency realm of our industry have been doing a really good job of focusing on energy efficiency and reducing the energy usage of our buildings as a primary means of improving the climate impact of our buildings, reducing energy, reducing climate impact. And that's really been a really strong focus. And so I'm going to use the term operational emissions to talk about the climate emissions that come from the use of energy for heating, cooling, lighting, plug loads, all those things. So there's one level of this accounting or this sort of quantifying of our impact that's looking at how much energy we're using. But we know that energy can be coming from different energy sources depending on what we're doing, and even from the standpoint of electricity, where our electricity comes from. So it could be coming from the sun, it could be coming from the wind, it could be coming from coal, it could be coming from natural gas or oil. Any of those different sources is going to have a different climate impact or carbon emission profile. Those are called the energy source emissions. So when we talk about the operational emissions or the climate emissions that come from operating our buildings, it's the amount of energy we're using times the energy source emissions for the energy that we're using to provide, or the fuel source we're using to provide that energy. So that's what we know, and that's really what our industry has been focused on to reduce our share of the climate impact burden from running all of our built infrastructure. And that's been not only has that been critical, but it remains critical, and we need to keep the bar really high there and continue to do really good work building high-performing buildings using renewably powered, efficient mechanical sources. That's absolutely part of the picture. But in that process, we've also been missing a whole lot of the pool of emissions that have been released, which is before the building is even operated, and it's everything that it takes to develop and produce these buildings in the first place. And there's two really big issues around that. One is that it's a huge amount of emissions that we just literally haven't been counting or paying attention to. And two, those are the emissions that are released the earliest on in the process. They've been released even before the owner moves in and takes occupancy. So if we're trying to meet near-term carbon goals, that's a big deal. And also knowing that those emissions stay in the atmosphere and persist as greenhouse gases throughout the lifespan of that building, those early emissions are some of the most impactful. And so that's what I want to focus on today, is looking at that whole other pool of materials that I think largely unwittingly we are emitting because we're just not aware of the scale of that impact. So that's what we're here to explore. So I want to give some definition around some of the terms and the timeframes and the scales. This can all get pretty complicated pretty quickly. So I'm going to stay pretty high level and just make sure that we're all sort of understanding the different stages that are out there and which ones we're talking about. So when we talk about embodied carbon, we're really talking about the climate emissions that can come throughout the entire lifespan of the building. And you can look at this on a per material basis, and you can look at this in the basis of the whole building. And so we're talking at the very beginning about the emissions that are released in extracting or harvesting the raw materials and then bringing them over to a factory and then turning those materials into products and then bringing those products onto a site and then building that on that site, all those materials into a structure. And then we've got the use phase of the building. And sometimes there are carbon emissions or climate greenhouse gas emissions that come during that use phase. I would say the majority of them are actually from the operating emissions that come from using that building. So we were talking about at the beginning, all the emissions that come from the energy usage to heat, cool, light, and otherwise electrify our structures. And then once we get to the end of life, we've got what it takes to demolish the building, transport the refuse away, and landfill or recycle it. And there's emissions that are released at each one of those phases. So when we're looking at the whole life cycle of a building, and all the emissions that are non-operational, not the operational emissions, but basically all the other phases of that, that's what we are referring to when we say embodied carbon. We break that down to a few smaller chunks and sections based on time. So this first one we'll call cradle to gate, or that's really formally like the material carbon emissions. That's what we're going to be talking about today and looking at when we're comparing different materials to each other and looking at the emissions of materials. This is the phase that we're talking about. And that gate essentially refers to the factory gate. So we are comparing materials to each other at the kind of endpoint of their manufacturing, knowing that there are going to be additional emissions that come from transportation and construction phase. We can get into those nerdy details in the Q&A for anyone that wants to get more granular there. The upfront embodied carbon, which is all the carbon that's emitted prior to occupancy, that would include transportation to the site and the emissions that are released during the construction process as well. Those can be a little more difficult to calculate. They are much more site specific and construction specific. I'm here in Vermont where it's very, very cold outside for half of the year, and there may be a whole lot of temporary heating being used to keep a building warm during the construction phase. That would be an example of something that would show up in that phase and gets to be pretty building specific pretty quickly. But if we're looking at reducing our near-term emissions, say hitting a goal of net zero by 2030, 2040, 2050, that's where looking at that span of the embodied emissions is also very useful. And then of course the whole life cycle matters too. I would never suggest that it's not relevant. It's just another level and scale of analysis. So as we get really into doing this work, we find ourselves kind of looking at multiple different scales at different times because we learn different things and can make different decisions based on whether we're really thinking about those end of life conditions and the whole span of a building's lifespan, or whether we're really just trying to make some decisions for some immediate material selection choices or hitting some near-term targets. So again, I want to reaffirm that we're looking at those the cradle to gate kind of material emissions right now. And we're kind of zooming on that for a few reasons. In the scale of construction that I think we're largely talking about, light frame, low rise, primarily residential or light commercial construction. I would say that, and if I'm zooming way out and talking big averages, the majority of those emissions within the embodied profile are in that material carbon emission cradle to gate phase. So that's where most of them are. So makes sense to be looking there. We also have some of the best data and can most easily compare and contrast different materials within that boundary. It gets more complicated and the data gets a little bit squirrelier and less accurate or more custom or a little bit harder once we start looking at the variables of getting to very specific sites from very specific manufacturing plants, so on and so forth. And the construction details of what emissions go into the construction can vary really widely too. So for all those reasons, that's why we're really focusing on the material boundaries of that, that cradle to gate there. So I mentioned, and Sonia mentioned earlier, EPDs, environmental product declarations. So that's essentially, for those of you that have not yet delved into the wonderful world of product transparency, an EPD is basically like an environmental nutrition label for a product. And so there are 7 different impact categories, environmental impact categories that are evaluated. We tend to really focus on the global warming potential category within that as our sort of value for climate impact. I want to be really clear in stating every one of those environmental impact categories has an effect on climate change. The impact to waterways has a huge impact on how well our oceans can draw down carbon dioxide from the atmosphere, so on and so forth. So I would argue that essentially any of those environmental impacts categories ultimately has a relationship with the atmosphere and the amount of carbon that's in the atmosphere. But the part that we're really looking at is the GWP, or global warming potential. And so that is when we start looking at the BEAM tool and some of the data that we're showing, that's the data source. And BEAM, the material carbon emission estimating tool, is using these EPDs either from specific manufacturers for specific products or from trade groups that are representing multiple manufacturers and their products. And so it's from them that we're deriving the sources of that data. And that's all third-party verified reporting that's done in a very sort of formal ISO regulated protocol of how those calculations are done. And we can nerd out on that as well for those that like to look behind the veil of product data. But that's what the basis is for all of the information we're going to be looking at and when we're working with the BEAM tool. The actual metric for that, or the value for that metric, is carbon dioxide equivalents. And I want to take a minute and define that because I've already been throwing the term carbon emissions around, which is actually pretty inaccurate and a real shorthand term for saying carbon dioxide equivalent emissions. And so carbon dioxide is maybe the most prominent and one of the longest lasting greenhouse gases, but it's not the only one that we release through the development of materials. Methane, a whole host of fluorocarbons and refrigerants and propellants are all released, some of which are many, many, many times the impact of a molecule of carbon dioxide. So it's really hard to look at numbers for 30 different chemicals. So the process is to look at what the equivalent impact of any one of those chemicals would be as if it was a molecule of carbon dioxide or compared to a molecule of carbon dioxide, and use that as the unifying value. And that's what the little e, the equivalent for carbon dioxide equivalent, means. So for example, methane within a 100-year lifespan has about 25 times the impact of CO2. And so that would be a CO2e value of 25. Incidentally, within a 20-year period, that's actually more like 80 times the impact of carbon dioxide. So it can get pretty technical pretty quickly. But when you see that CO2e, we're referring to all greenhouse gases as a sort of unified value of what the global warming potential is of that given material. All right, so let's look at actually how we get from this raw data source into making quantifications. So when we start getting into the details, you have a sense of sort of how those numbers add up. So we start with an EPD and looking at, let's say, timber or concrete or steel, we see per unit of weight or per volume, we've got a certain amount of emission. We can see that right off the bat, comparing a volume of timber to a tonnage of steel I don't really know what to do with that. Can't really actually do anything with that with only this much information provided. We can see that the steel number is bigger than the timber number, but would you necessarily be using the same amount to achieve the same purpose, or how do you really compare these? And so part of the value of the tool that we've developed is to take a lot of that work out of your hands and putting it into a tool that does a bunch of those calculations. So the way that works is we've got all of those factors, those global warming potential factors, a certain amount of carbon dioxide equivalent per unit. Could be unit of area, unit of volume, unit of weight, what have you. And then we were making a reduction for materials that have that viably store carbon in the body of the material. And so now, instead of when I say carbon storage, I literally mean carbon, the element carbon. And so when we're looking at something like, I'll use cellulose insulation as an example, that cellulose insulation is almost an entirely recycled product. So were that paper not turned into insulation, ultimately within, nearing the end of its paper lifespan, were it not turned into more paper, it's going to end up degrading and ultimately re-aerosolizing to the atmosphere and completing its carbon cycle. Carbon's always moving in a cycle. It may be a short cycle, it may be a long cycle. And so the process of taking that paper product and banking it into a building means we're storing that paper in the building as a viable insulation product for the lifespan of that building and keeping it, interrupting the cycle of it going through its end of life cycling of being burned or decomposed and then re-aerosolized into the atmosphere. So we feel like, okay, that's relevant to give that material a storage credit. We're intentionally taking that material and storing it in the building for a period of time. The way we value that is looking at the amount of carbon that is in that paper and being able to essentially reverse calculate or reverse engineer the amount of carbon dioxide that was photosynthesized as a tree to be able to create the amount of carbon that is in that paper. So it's a mechanism of being able to give a legitimate storage credit to bio-based materials that ultimately were formed from carbon dioxide that was drawn down from the atmosphere. And so we can talk a little more about that, and that's maybe a novel concept, and there's a fair amount to unpack there and lots of details, but that's the general idea behind carbon storage or negative carbon emission values for some of these bio-based materials that are not otherwise going to be photosynthesizing. So that's how we kind of get the basis of our the global warming potential factor of a given material. And then we have the material quantities that you, as the user of the tool, have inputted around your building. How many square meters or square feet of different areas of different assemblies. And then that, that calculation is done in the tool to give a net emission value. This is how we're getting that number at the end there, the net emissions in kilograms of CO2e. That's the global warming potential of all those different materials you've entered based on the amount of materials that we see are being used. So looking back at that initial question, how do I compare the timber and the concrete and the steel from these EPDs? When we factor in equivalencies of a 6x6 post for timber versus a 6-inch diameter post for concrete versus getting away with a 3.5-inch diameter post for steel because it's because of its structural performance, we get what the sort of the net emission values are for each of those different products, and we can kind of compare them against each other and make some real decisions around what we want to use to frame out this building. All right, so that's the sort of methodology and data sourcing behind all of this stuff, so you have a sense of where these numbers are coming from. I'm going to look at the beam tool here, and I'll just say, for those of you that are totally new to this and just learning about some of the stuff for the first time, I should sort of append to my introduction here. One of the things that I do with Builders for Climate Action is help develop and train on this building emission accounting tool, which you can download for free on our website. So when we're done here, and I'll throw up a URL at the end of the presentation, that's where you can go and get yourself a free copy of the tool so that you can get access to running these calculations yourself, just to be clear where this is ultimately all leading towards. So we can use that tool in a few different ways, depending on where you are in the design process, the construction process, or what questions you're looking to answer. So on the most basic level, and probably most apropos of the sort of focus for today's conversation, is doing direct material comparison and looking at how can I look at the impact of one material versus another and make some direct exchanges. This is a screenshot from the tool, so it gives you a really good, clear sense of the visual format of listing all of these materials against each other to be able to do some direct and immediate comparison. So you will input where your R value is for your cavity. Say it's R20 going in that frame cavity. And then you can look here and see for all these different materials, kind of organized by the material type, what would be the embodied or the material carbon emissions for any one of those different choices. And so a great example here, I don't want to bury the lead and wait until the last couple of slides to tell you, hey, here's what you can do to reduce your emissions. There's a really huge difference between an HFC versus an HFO type spray foam. And that's referring to the chemical constituent of the blowing agent. So you can use different blowing agents to spray foam into your building. If you use a lot of spray foam, you love spray foam, you don't want to stop using it for something else, you can reduce, like a 3 to 4x emission impact just switching to a more modern, lower emission profile blowing agent. And these are all materials that are fully proven and out there in the marketplace, vetted, verified, roadworthy, and ready to go. So this just gives an example of how you can do some direct comparison within any given material class or across different classes and say, oh, maybe rather than spray foam, I'll use something else for an air barrier and switch to a sheet wool insulation. And now we're talking about an order of magnitude reduction in emissions. Or maybe you're in a good place to use open cell if you've got the vapor profile managed well in that building, and you could get by with an open cell application there. So it gives you some sense of what how you can just do direct material comparison within any one of these categories. You can jump out a scale from there and look at comparing different assemblies. And this would be, all right, well, we're looking at a couple different options of how we want to frame up the windows or build out the walls for this next project. There's a version of this in which we use frame wall construction. So you have an input for your 2x6 lumber, for your sheathing, for some mineral bat, and maybe a foam board, an EPS board rack. And that would give you 1,500 kilos of emission for your building. You can compare that to if you were to use ICFs and a concrete fill of a certain strength rating and a certain amount of fly ash, which is one of those supplementary cementitious materials, or SCMs, that Sonia was mentioning before. That would be a good bit more relative to assembly 1. And looking at assembly 3, which would be a SIP panel using a EPS core, that would be somewhere in between those two. So this is a way that you can model out different approaches or different combinations of materials within your assemblies and be able to make some decisions on that level. And then, of course, you can just run through all the products in the building and get kind of a building level evaluation of where you've made decisions to use a little more carbon in the basement, or maybe need to find some carbon storing solutions or super low carbon solutions elsewhere. You can look at the really approach number 1 in this case from this whole combination of materials is getting a 81,000 kilos of emission, whereas if we're really trying to make improvements kind of across the board in a number of different categories, including insulation, including framing, so on and so forth, we can reduce that building emission profile quite considerably. And that's a way of really zooming out to the more of a full picture of the building and looking at comparisons on that level. I want to be clear that this is not whole building life cycle analysis. There's plenty of materials that are not captured in here. I'm going to talk about those in just a minute. So this is more building up of all the primary materials in the building, kind of from their components on a sort of per category, per assembly basis. The way that I like to think about this is somewhat through the design phase, and I'll acknowledge that I've kind of moved into the design world a bit more. I would say there's a similar level of analysis and questions you can ask, even if you're a builder and entering in with a design in place in terms of, or if you're doing the design as part of a design build process, the sort of the scales or gradations of questions remain the same, but I'm organizing these based on design phase. So schematic design, that early phase, you're deciding, are we going to build, are we going to do a remodel? What's the sort of location of the building and how does that impact its massing, the size, the shape? What are some of the early phase materials you want to look at? So in that phase, you can actually make the most amount of change with the fewest moves and the least cost when you're the earliest in the process. So even though you may not have all the information, even though there may be a bunch of stuff you still don't quite know, it's a great time to start doing some really early modeling. Just get a sense of, hey, if this is a 12-corner building instead of a 4-corner building, how much of an impact is that going to make? Or, you know, we're thinking of doing this as a masonry structure instead of a wood frame structure. You can at least get some of the early input back at a time where you can make changes and really affect the trajectory of the design with some of that information background. Well, what is the climate impact of some of these decisions? As you get further along to design development, then we're really looking at the details of all the layers in the assembly and really getting more specific on what materials are being preferred for your insulation, for your framing, for your sheathing, so on and so forth. That's where you can really start to build out a full model and really look at those assembly comparisons and maybe looking at full building scenarios. You're probably going to pay a penalty if you need to start changing the shape at that point in the game, but at least you still have plenty of control over what materials are going to fit into that building. And then by the time you get to construction documents, really you're looking at getting product specific and you're really moving towards procurement. And that's where getting the EPD information that can draw distinctions between product A versus product B. There can be a really big range, as we'll explore. In certain materials, there can be quite a huge range in what the carbon emissions are, even though they are both, you know, a batt insulation product that's made from the same material. So that we just looked at HFO and HFC spray foam as another good example where you may be able to get product specific on the based on the chemical composition and save 4 times the amount of carbon for that material once you're already decided, yes, we're going with spray foam and this much of it in this location. All right, so just to be really clear about what is and is not included in the numbers that we're going to be looking at, we're really looking at structure, enclosure, partitions, and all the primary finishes, I would say, like your drywall, your siding, so on and so forth. We're not including mechanical, electrical, and plumbing because we really just don't have good enough data for that. Although stay tuned, we're working on that now and look forward to having that included in the tool in the not too distant future. Appliances, finishes like paints and stains, millwork, a lot of those things are not included either because we don't have good data or they're not particularly actionable in making kind of core decisions around the design, or they're just too variable and outside of the modeler's purview. It may just really be up to the owner to take, especially when you get down to a furnishing level. So I'm going to just show, just to give us some reference of like, how much emission are we talking about? We've done a bunch of studies, Builders for Climate. Actually, I say we have had a relatively small role relative to others in the team, Melanie Chatier and Chris Magwood, and others doing some really good research of a bunch of buildings, looking at, well, what's the span of emissions that we're seeing from our currently from our building stock. Some of the highest results are in the 300 to 550 kilos of emission per square meter. These are Canadian studies, so hence the metric denominator, but just as a basis of comparison, a lot of those sort of average results are quite a bit lower, you know, half of that, you know, a third to a half lower. I'll note that the Vancouver homes are likely to be very similar to the houses that you're building in the Pacific Northwest, and so even the Nelson and Castlegar buildings are not all that dissimilar from buildings that I'm expecting all of you are building. So I would consider these directly referenceable. And then looking at some of the absolute lowest results from within that pool of evaluated buildings, we got some very low emitting buildings in there. So quite a big range of this is what's already out there, not what is potential or what was modeled or designed to get the lowest possible emissions. This is just what folks are building out there right now in the marketplace in real time, and the span that we're seeing. And so what does that mean at scale? I think is really relevant because when you're going building by building, it can feel it's hard to feel like, hey, if I'm swapping out this batt insulation for that batt insulation, really, how much of a difference does that make? Do I really care that much to go to the trouble? So what I'd argue is, yes, we are all part of a movement in which the accumulation of all of our activities is making an enormous impact. And so looking at the average emissions for 800 of these new homes in Canada, a rough average being about 200 kilos of emission per square meter. You multiply that out by the number of low-rise residential construction in the US 5 years ago. And again, that's about 5 years ago. And that's just low-rise residential construction in the US. And we are equal to or greater than the emissions of some really major countries in their total net emissions. That is a really big amount of global warming potential impact that our industry is having, which to me implies two things. One, we have a responsibility, but two, we have an amazing opportunity to really intervene in a very meaningful way in drawing down some really big numbers through some basic material swaps. So looking at what those material swaps can be, we find that the vast majority of those emissions for low-rise residential kind of wood frame construction is showing up in concrete, insulation, and cladding. So if you're just looking to like walk in the door and start, trying to make some initial moves and reduce your impact somewhere without wanting to get super invested in the comprehensive study, boom, there you go. Those are like the three major categories that we see the bulk of the emissions pools showing up within. Again, of the areas that we're able to look at. This is not including mechanical, electrical, and plumbing, which is would be another big category. And so, as we're starting to come up with a strategy of what to do here, for me, as more of a planner type of a person and someone that's always likes to have a goal in mind before I start making a lot of moves and changes, that's my nature. I find it really helpful to kind of orient around, okay, are we just trying to like swap out some bad insulation, or is there something, is that in pursuit of something larger? And what I'd argue is that, again, we've done a really good job of making our buildings energy efficient. We're now understanding that how that energy is provided makes a difference too, and combining those things together gives us our operational carbon emissions. Now we're talking about material carbon emissions, and it's pretty easy to fall in a trap. We're comparing those things together and saying what's more or less important or higher or lower value. Our argument is that we really want to look at those things together ultimately and reduce the total carbon use intensity of our buildings and really find ways of bringing both of those down. So the idea is that we're still building high performance, super insulated, airtight, low energy buildings, but using low carbon or carbon storing materials to achieve those same goals. And that's really the sort of the model that I'd like to present as we look at doing these reductions. I'm not suggesting you use less insulation. Please do not hear that. I'm suggesting we use all the same amounts of insulation, but use better materials that emit less carbon to be able to achieve those same performance goals. And so just, again, looking at those things in scale to get a sense of what the scale of impact is here, we can look at, again, looking at the study in Nelson, BC, you got about 30 tons of material emissions before the building is occupied. If we look at an average of 1.25 tons per year in how it's being operated, that's a big average. There's a lot of variables there, but using that as a simplifying assumption, we find they have about 54 tons of emissions over a 20-year period, which means it takes about 23 years before the operational emissions are equal to those initial upfront material emissions. And that gives some scale of how big those upfront material emissions can be, particularly as we improve the energy performance of our buildings. If we're looking at the worst case scenario, all these numbers just become really huge. And there's opportunities to reduce that all over the place. And again, why I'm really informing that we don't want to see our energy usage and operational emissions go up in pursuit of lower material emissions or vice versa. The best scenario is when we've got the best, lowest carbon solutions, both for the materials themselves, as well as having a high performance building, low energy building on a very clean grid. That's where we can get to some really low load buildings and start getting towards these net zero emission goals that our industry is really working towards. All right, so with the time I have remaining, I really want to kind of get into the details here. I've already started looking at some of the particular materials, and I want to just sort of dive into that for the rest of our time here. So on a high level, looking at strategies, we sort of looked at where the pools of carbon are on like a building assembly basis. It's the insulation, it's the foundations, and the cement, and the cladding. Looking at from material basis, concrete, steel, aluminum, glass, and plastic. Kind of like the big five where we see the most of the highest emission profiles of the materials that we put into our buildings. So we want to reduce our dependence on those while also increasing the use of materials that have negative emissions, those carbon storing materials. Now it'd be agricultural residues like hemp or straw. Those are some of the highest carbon storing materials we can find. Waste and recycled stream fibers, that'd be like your cotton bat insulation or your cellulose insulation. Purpose grown crops that are grown specifically for not as an ag residue, but being grown for the purpose, like the rice hull product, the acre rice hull product might be an example of that. And then timber. I'm going to put a big asterisk at the end of timber because there's a version in which that tree stays photosynthesizing carbon dioxide in the woods. And there's a version of it in which that forest is still able to provide all of its ecosystem service of photosynthesis while also still having some timber products be removed from the forest. And the difference between those two is really the difference between whether we could value the timber as a carbon storing material or not. What's the net impact on the atmosphere based on how that forest ecosystem has been managed? That can be difficult to figure out just looking at EPD or even with the data that's available when you go to place your next softwood framing lumber order. So for the sake of the beam tool, we're currently taking a conservative approach and not valuing carbon emissions, carbon storage for virgin timber products, just because we don't have good transparency yet or a good methodology in understanding, well, would that actually be a net benefit to the atmosphere for that tree having been harvested? Looking at those study results again, and you can see that we've got a 30 to 50% reduction from the average down to the lowest results. I consider that that's the range that we have to play with for existing market, not even market ready, but market delivered residential construction. And so that's sort of the scale and the target that we would expect to see is within our grasp, within our range in the market today, not looking at the super ultra, kind of edgier or alternative materials and assembly approaches. This is just what's being built right now. To get into some detail here, I'm going to kind of look at these in a number of different ways, knowing that we're coming from some different backgrounds in the room and we sort of can digest the information in different ways. So I'm going to kind of package this up in a few different examples of how we can see reductions in which materials to focus on. So, looking at some 44% reduction from an as-built set to the best available materials sort of commonly on the market, switching your cavity insulation from fiberglass to cellulose is a huge savings, particularly because of this carbon storage value of recycled paper. Going from a mineral wool board to a wood fiber board, similar benefits. This is maybe using a lower emission profile with cladding. This would be using the lowest emitting option of the conventionally and normally available drywalls. Now we're at that sort of product specific level that you may be getting to as you get into procurement or construction documentation. Switching your flooring from a hardwood flooring to a bamboo flooring. And this is sort of acknowledging no credits for storage value for the hardwood. Again, using sort of the best in class or lowest emission profile of a series of different of the sort of below grade insulation boards where it'd be a lot harder to use a bio-based product. And reducing the emission profile of the concrete to a lower emitting version of the concrete. So you're sort of, and again, the lowest in class, lowest emitting version of a mineral board on a product level. And we can reduce 40% of our emissions just by making those changes. Those are all changes we consider to be either cost neutral or at close cost parity, and are currently available through normal supply chains. And looking at that list of vendors that you all have access to is amazing. I mean, that's a phenomenal list of vendors and low emitting and storing materials compared to many parts of the country. So you all are super well positioned to make some of these changes. And then of course we can go all the way further to really leaning into the carbon storing solutions and getting some ultra low profile buildings. And I recognize that's a little bit beyond what we're talking about today, but just gives you a sense of the potential as for those of you that feel continually motivated to get further down the path of low emission and low carbon building. There's a long road ahead with a lot of good opportunities there. Let's look at this another way. This is from a company, Doug Terry Homes. And BFCA did some study on some of their their model homes. And this is looking at one of these buildings where their as-built emissions was a total of about 66 metric tons of emission. Using some revised insulation that was able to come down a bit, and using a batch of just these one-to-one, kind of near term, could be rolled out in the next 1 to 2 years substitutions, we're able to make, in their case, a 65% reduction. So looking at what some of those materials are, That's looking at concrete, starting to use, in their case, high slag. That could be kind of any SCM or other similar, Portland cement reduction mix. Replacing the closed cell spray foam with EPS foam board below the slab, using cellulose insulation for cavity insulation, using cork and linoleum flooring instead of conventional carpeting and hardwood, and replacing the brick with engineered wood cladding. Those are the changes that they made to be able to achieve those reductions. Looking at that, for those of you that like to see hard numbers, just to kind of highlight a few of those, you can see the scale of reduction just by introducing that slag into the footings and pads, keeping the rebar the same, keeping the reinforcement the same. Once you get to the slab floors, just being able to put that amount of slag in the slab was able to receive, a similar reduction there. I recognize from experience that that's not always easy to do for slabs. And it will depend on the nature of the timing of your pour and the finish level of that slab. But some other options like going to a plywood or floating or slabless slab, or even going to a cob floor for those of you that are going for sort of the ultra levels of innovative materials, you can really draw those numbers down further. Looking at the subslab insulation, again, the swap from an HFC to an HFO product would get you, a twofold or 200% reduction or so. Going to a graphite-based EPS brings that down even further still. So on and so forth. I won't read through all of these in the interest of time. You get a sense of that's for the sub-slab. We looked again similarly at what the foundation walls would look like, some additional savings for the similar moves around the concrete or the cement offsets in the concrete for the walls. Again, as well as for, this is another really interesting thing to look at on a product level, the difference of emissions between older generation blowing agents in the average XPS foam board versus DuPont now has a reduced global warming potential product. Sopra has a product that is like an, order of magnitude and then some lower. And these are all, within the class of XPS foam boards. So these are the types of ranges that we see within a given product class that give us a whole lot of leverage for being able to reduce our emissions just from making product selections, without even having to get to the point of swapping out to a more innovative or kind of edgy new material. So on and so forth. And then looking at the exterior walls again, so we see some really similar patterns here. Even keeping some of the sort of framing systems in place and just making some of these insulation material swaps, again, sort of within the cavity and within the continuous board insulations, make these really large moves. And these are making material substitutions that are, really don't involve any direct conversation with the client as it relates to aesthetics or the sort of their direct experience. Some clients have a really strong interest in what's inside their walls and buildings, in which case this gives an opportunity to have a really informed conversation around material impact. Many clients don't care, in which case these are all moves you can make without having to make it a yet another thing to bring up and get into dialogue with the client if that's not currently your practice and you're not trying to engage them so directly in that conversation. So a strategy of like how to start walking your way through this and kind of wrap up here with sort of how do we apply this stuff? Because that's a lot of different moves. You can make it in a lot of different ways. A really simplifying approach here would be like walking a series of steps more incrementally from now towards a goal, say 40% reduction by 2030. That may feel overwhelming to do in the shop. So, and again, these are not going to be all like exactly 5% reductions here, but roll with me. Some simplifying examples of a series of small, roughly 5% steps here. Year number one, you just improve the SCM content or the cement reduction approach to your concrete. Year number two, you swap out one of those insulations. Maybe it's your sub-slab insulation. Then year three, you switch to the lowest carbon available drywall. That's your big move for the year, is changing your drywall spec. Year four, you make another change in your insulation. Maybe now you're looking at your cavity insulation and making a swap there. Year five, you focus on your cladding and you find a better cladding product that has significantly less carbon and you kind of roll with that as your new cladding approach. Year six, you approach your flooring. Now maybe you're bringing some additional finishes in front of the client. You find a profile of flooring solutions that are significantly lower impact than the ones you've been previously speccing, and then maybe now you're changing that board installation for your enclosure wrap in year 7. And so if that incremental approach, just looking at one material at a time, feels a little bit of an easier way to walk forward into this, within that 7-year period, you can get to a really significant reduction. This is a familiar pattern. This is exactly the way our industry has reduced energy consumption by a really significant margin over the last 20, 30 years. It's been an incremental step change through consistent code improvement and technology improvement steadily over time. So we have precedents for being able to achieve large things without having to dramatically and radically redo your business model. So to wrap this up, just with a little bit of sort of like inspiration, some context, some scale. Right now, this is just like a quick smattering of projects that are either very close to or below net zero embodied carbon that are out there in the marketplace, some of which are work that we've done, some of it from our colleagues and friends that are sort of market viable, proven, ready for prime time solutions. So this is not a technological problem to solve as much as it is a sort of a comfort level, I would say, and a sort of a risk aversion problem to solve in terms of what we're willing to accommodate and how far we're willing to go in adopting some of these new technologies. As a longtime straw builder myself, I like to just give a little bit of a shout out to straw, partially because I feel it's undervalued, and partially because it is literally the best way to bank carbon and get negative emission values in your building. So for those of you that consider that to be like some fringe kind of hippie building material that's super hyper custom, these are prefabricated panelized walls that are being built for mid-rise, multi-unit and commercial scale, as well as looking at hempcrete and mass timber for heavy structural solutions as well. So a lot of the things that may seem edgier and far out of grasp, I assure you, are being done today and within the grasp, but we can start that journey with single steps. And I hope you have learned a few of those steps over the course of the last hour. Thank you for your time and attention. I look forward to your questions. And head on over to buildersforclimateaction.org to download your copy of Embodied.
Well, thank you, everyone. We will be switching over to our question and answers time of the webinar. We do, if you don't have time to stick with us, we would appreciate if you would visit our survey for attendees and give us your feedback on how this went and maybe what you want to see in the future. Please fill out that survey. If you don't have a chance to fill that out now, we will be emailing it to you later. And with that, I'll leave this up for a minute in case people need to type out the address for the survey, but we are going to open this for questions and answers. Feel free to turn on your video and your mic at this time.
I have what sounds like a really dumb question. Hi, Sonia, and hi, Jacob.
No such thing. Hi.
Hey, no, there is. I have 3 children. There are dumb questions. No, so really, it popped into my mind, and it's probably a simple answer, but do the eco-building materials cause a high, especially in like these mid-rise builds, do they pose a higher fire risk? Or like, because that's like my first thought with like the straw and things like that that are flammable. Is that something that comes into concern with insurance or anything like that?
It's a great question. So it really depends on the material. So I'll start by saying that we have to look at a material by material basis. In general, I'd say, well, so you referenced sort of mid-rise construction. I'll say the microscope for code viability in that so that realm of construction is much more finely attuned than for residential construction, at least in my world, where I come from. So nothing's going into those buildings unless it's passing, passing fire ratings and the like.
Of course,
So speaking to, I'll just name a short list of the bio-based, primarily insulation materials that sort of get questioned. You led with straw. I'll respond to straw as a straw builder. So plastered straw walls have been ASTM tested and rated as Class A firewalls. So the Now, not every straw building is applied in that way. Panelized construction may or may not have the same level of testing, but I can say empirically from seeing many buildings go through wildfires as well as some house fires, straw behaves very similarly to timber. It chars, but does not ignite because of its really high density and the oxygen deprivation of the material, let alone the fact that it's generally within an airtight assembly. And so it's missing the critical oxygen that's required, which ironically is often in very high supply for, say, like a low density bat insulated cavity wall. So that's a sort of a general answer on straw. Cellulose and a lot of the wood fiber products, like you can now get, well, you've been able to get European source products for a while, and they're just this year, there's now domestically produced wood fiber loose fill board and bat insulation being produced by Timber HP out of Maine, close to me. All of those like cellulosic and wood fiber products are all entrained with borate as a mineral fire retardant. It's kind of like 20 mule team borax is like your probably closest domestic consumer equivalent thereof, right? So it's a mineral-based fire retardant, and I've done demonstrations for my classes for years where I'll have like a nest of cellulose insulation, which is literally shredded newspaper, or actually, since no one reads newspapers anymore, now they're using paperback novels, pulp fiction, if you will. So I'll take a nest of this stuff in my hand, throw a penny on there, and torch it with a pencil torch and melt the penny. Holding just a small nest of this in my hand. It's like incredibly effective in the manufacturing of those products for using a mineral as opposed to a more chemical-based fire retardant for fire reduction. So that's that's a short list of a few of those. Yeah.
Okay, awesome. Thank you so much.
I'll also add that hempcrete, I believe, has a self-extinguishing sort of property, and wool insulation also has a similar kind of natural, it's also treated with borate as well, but wool itself is somewhat self-extinguishing naturally without the additive, but they just add the borate as additional. So many of cork is also self-extinguishing. So a lot of these natural products are inherently naturally fire resistant.
Okay.
And they are code approved at this time in our state.
Very cool.
Build with all of those types of products here.
Awesome. Thank you.
Yeah, code approved.
Yeah, cool. And I would say as you get into my experience, as you get into the multi-unit buildings, and particularly where you have close adjacencies between buildings and urban environments, sometimes the code thresholds can get a little bit higher. And you may find on a product to product level, you may or may not have the correct UL listing or sort of, certification that will make it really easy to sail through. So if you're considering using some more of these edgy materials in a more code intensive environment, it'll get maybe product specific. For example, some of the panelized straw products aren't all necessarily stamped for that application in the US and may require a little more review. But to Sonia's point, there's a tremendous amount of testing and data behind all of these. And many of these products are fully stamped and viable for full, dense urban commercial mid-rise application as well. So
cool. Yeah. Awesome. Thank you.
Mm-hmm. Yeah, and just to piggyback off the straw bale conversation, Eric Moss asked, where can you source straw bale panels? I don't know if we have them locally sourceable. Jacob, do you know if there's any vendors that are maybe US, Canada based that could source from?
Yeah, so there's 3 companies I can point you towards immediately, and then others that are coming along very soon. So New Frameworks, that when I put my other hat on, we are producing prefabricated structural straw panels under the name Griffin. So if you go to newframeworks.com, look for Griffin, Gryphon. There's another company over in Maine called Croft, Croft. That's producing panels. So there's a European company, ecological, which has a deep bench and a long history of doing straw panels for passive houses, and dozens and dozens, maybe hundreds at this point of passive houses throughout Europe. They're now importing into the US. And so that would be another company certainly worth looking at. They're importing via the East Coast as well. And there's a company that's starting up in California. I would direct you to the California Straw Bale Association, CASBA, as a good source for what I don't want to say their name yet because I'm not sure that they're fully public or if they're about to become public, but check out Casbah or contact me offline and I'll make sure I've got permission to release their name. They're on the verge of releasing their product. So we'll see more and more of them as we move forward into time. There is one thing I totally forgot to mention that I was told from my BFCA colleagues I was supposed to mention and completely forgot, but I want to mention before I lose you all. We are offering a training for the Beam tool coming up in March, next month. So for those of you that are like, sweet, I would love to start doing this, but I could use a little more guidance, a little more information, please go over to buildersforclimateaction.org and there's information on there about the next Beam training. It's like a broken into 3-part series, so it doesn't absorb too much of your time and focus, makes it a little bit more digestible. And it's a really awesome way to just sort of dive right in and start using the tool and make some improvements immediately with a little more guidance.
Jacob, we'll make sure that link is in our follow-up email.
Awesome, thank you, appreciate it.
Mike, I saw your hand up for a while. Go ahead. Mike Nickram.
Hi, Jacob. Yeah, thanks.
Hey.
So Jacob, I'm a builder out here in Seattle, have been for 40+ years. I'm also a deep foundation contractor. Install helicals, micropiles, grouted piles, so on.
Awesome.
And it's intriguing to me to think that now in Seattle, I'm pushing 70+ mile round trips to get rid of dirt, right? Export, import, imagine that cost. And with a helical pile, I can just simply grade a site, drop a pile, put in a treated wood perimeter beam foundation, right? Mm-hmm. And you can imagine the savings from there. Has Beam been able to take in that type of calculation? And FYI, I think I can do this competitive with standard stem wall foundation systems.
That is awesome. And like, yes, go, huge helical peel fan. Helical, piers and piles. There is a line item for helical piers in Beam. It's got a embodied carbon value and you can plug that in. And I think you really hit upon, I would say, one of the like primary strategies. So I was really trying to focus on like, what are the simple, easy, like walking in the door moves that don't like totally disrupt your business model or your approach to building. What you're suggesting, I would say, is like, a significant change for many folks that are used to just pouring concrete all over the place. It's one thing to reduce the cement content of your placed concrete, of your ready mix, and that's awesome. If we can do that, we're doing great. But that's pretty low order. I would say way higher order is just not needing to use the concrete in the first place. And when you talk about, particularly in the case where you're at, I mean, I'm in a more rural part of the state, so the trucking is less of an impact. But oh my gosh, if you're sending trucks 70 miles in each direction for every load. Talk about that construction phase emissions that's not being shown in the tool. Like that is huge. That's such an enormous impact. And that's where being able to take another step out, like, is there another technology? Is there another construction approach? This doesn't require the same volume of this material. That's when we start shifting from like a doing less harm to like a actively doing good approach and really seeing some of the next levels. If you can do that at cost parity, then like, oh my gosh, it's really hard to find a bunch of arguments other than inertia to not making some of those moves. But yeah, you could absolutely model that out in Beam. Empirical piers are in there. You could add whatever heavy wood construction or heavy timber construction for your grade beam would be, would follow suit. And then you just have a whole bunch of concrete that you don't need to include in your model, and it's going to show up as a much lower burden.
Yeah, and Mike, thank you for pointing that out. I was also kind of, looking at sort of our typical builds when listing off some of the products and strategies. So I will, before we send out the slides, I will make sure to add those the piles into the list of available products to consider.
That's awesome.
I have a question, Jacob. How do you feel for, some projects you have a partially below grade or, daylight basement. How do you feel about pressure treated wood foundations as an alternative to concrete? There's been some discussion of that on the Passive House Accelerator Forum recently, and a lot of people kind of liking the idea.
That's a big one. That's a juicy one. I have an opinion
about it, but
yeah. So I am going to reveal my East Coast, Northeastern bioregional bias here pretty heavily in my response, just to sort of acknowledge that. not a really great durability track record in our part of the world for those. Like we've seen a bunch of consistent failures with that approach. Not like all of them fail, but enough examples of failures and it's a reduced lifespan that for all of my championing of straw, I'm actually pretty conservative from a risk management standpoint when it comes to building. And so I tend to shy away from decisions that are really going to significantly impact longevity for buildings that I'm expecting a 100-year plus lifespan on. Now, I've definitely used those in applications where there isn't the same pressure of longevity and durability. But for that reason alone, I tend to shy away from them. I'm also really aware of the groundwater contamination issues that can come, particularly where we're from. There is so much groundwater and we have really intense water quality issues. And I try to avoid situations that reduce one environmental impact by creating another. And so I've not really leaned into those for those two reasons. And I would not say that that doesn't mean that it's not actually a really important and viable solution to have in our toolkit. And I think there are probably parts of the world that don't have the same degree of groundwater presence, or where durability and frost action is not nearly as intensive as it is. I'd be like, yep, that probably works better in that climate, is less of an environmental risk, and compared to the alternatives, may actually hold a net benefit. I totally see where that could be applicable. For my own practice, it's been a bigger lift, and I've leaned in elsewhere.
I guess the second half of that is, we have a project that's being designed with the plywood no slab floor.
Oh yeah.
Have you thought of any alternative for the structural concrete part of that, or is concrete what we've got? Just
good question.
Just concrete we can get.
Yeah, it's a real tricky one. I mean, so I'm excited about some of the compressed earth, stabilized compressed earth block products that I'm starting to see show up, and there are now starting to be some more tech-oriented, ultra-low emission CMUs that are using alternative cements to Portland. And I'm going to have a hell of a time trying to come up with those on the fly, but I come up with a short list very quickly once I'm not in the middle of a Zoom, and come up with some of those. I feel like those are going to make it really easy to have some better drop-in replacements. I think in the midterm, I've seen some really good innovative uses of stabilized earth, like earth bag or ram tire solutions that are much more edgy and labor intensive and non-standard, but can get to the same structural requirements without the need for Portland. I think for most of us that are in kind of the conventional pricing structure of building deliveries, where we really need some ground contact structure, I don't actually think that concrete is this horrible material. We just use more of it than anything else on the planet next to water. So I just think the issue is not necessarily that Portland cement is horrible and concrete is this super high emission material. I'd say HFC blowing agents and closed cell foam, we should stop using those immediately forever. I feel really confident just putting the stake in the ground on that. Cement, I'd say could we just use target amounts of it where directly necessary to transfer load onto the ground? And then everywhere else, we don't need 4 inches of it to make a floor. I'm going to say that's not necessary. We have other ways we could do that. And so, okay, that's where the slabs make sense to me. If we have to use some concrete in some specific locations to satisfy structural requirements and fit within the general conventions of project delivery, that's not blowing up a budget or bringing in some very unique labor force, I'm great. So then balance that off by using more bio-based installations, and you can still get to a net zero carbon building. That's where looking at the whole picture of the building is really useful. You can make an intention to invest some emissions in those key locations, work like hell to really keep them as small as possible, and then make decisions for other parts of the building to help offset that by using carbon storing solutions.
Thank you.
Yeah, thanks for the question.
Excellent. Thank you.
Yeah, I'm going to keep our questions going. I know we have 2 hands up and 2 in the chat. So I am going to cover the chat questions real quick, and then we'll get to the people with their hands up.
I'll
Thank
try
you.
to keep my answers short if I can. I'm not quicker than that.
So the first one is related to like salvaged and reused materials.
Oh, great.
Kate asks, is there emission ratings based on reuse of materials? For example, hardwood flooring that is repurposed or siding that is reused or purchased from a second use vendor? Great
question. Yeah, so right now, both within Beam and then what I would say is sort of from what I have seen, or so the predominant methodology around use of materials is that the carbon's already been emitted. You don't need to double count it and count it as if it's a new material. The material is existent. The carbon's already been released. Use the material again. That's great. Now, that said, a lot of reused materials require some degree of remanufacturing, refashioning, refitting of the material in some capacity. And I generally see that showing up in two cases. When it's within a manufactured product pipeline, that's generally showing up within the accounting of the emissions of that material. So for example, cellulose is using recycled paper. And the fact that that's the feedstock shows up as a very, very low, in fact, a carbon storing value for that paper. Even if you take the storage out of the equation, the initial, like the beginning of the life cycle of that product is paper. It's not a tree. And so from when you're looking at a product with a high recycled content, I expect that that's already been accounted for within the accounting of that given product. When you're talking about this, I'm trying to look at the chat and talk at the same time. You talk about hardwood flooring, for example, or reused siding. That would be something that I would expect it would be more within the category of like on site. Someone is running a sander and refinishing the boards, for example, so on and so forth. That's a little harder to account for. It's super custom. It's totally dependent on like, what was the conditioning? Can you slap it back down? Is it just, you don't have to touch it, but you're maybe only able to use 70% of it? Are you like, are you really having to use a bunch of energy or create a bunch of waste and so on and so forth? That gets to be more custom in the calculations. And a lot of the times when the refurbishing is really limited to like one person and a plug-in power tool, I generally see that not being accounted for. It's like noise in the larger calculation of the emissions. And so like, hey, you're using recycled material and avoiding all of this new manufacturing. If you need to run a sander for a day, that pretty much just gets rounded out. That said, some of these reclamation products can be pretty intensive and use some pretty intensive tools. And then I would be looking at what level of custom calculation may be required just to get a sense of what that is. And there are folks that are deep in the reuse and reclamation world that I'm sure could give a much more sophisticated and nuanced answer to that. I'm going to recommend the Carbon Leadership Forum as a source for anyone that's really looking to nerd out and deep dive and find your own little micro communities of folks that care about this stuff. It is an amazing international network of folks that you want to find the biggest like concrete scientist geek in the world, you will find them there. And you want to find like the international material reuse and demolition experts that care about carbon, you will also find them there. So that would be a good place to find your people.
All right, next question. Eric Moss writes, what is the best strategy when working with local jurisdictions during permitting when proposing a design utilizes Beam products materials they don't often see during review process or that is not in their code? Great question. As a 25-year-long straw bale builder, I am super familiar with this. My strategy has always been engage early and often and bring cookies. And maybe not the cookies, but you get the idea. Like you are best served by developing a proactive, positive, engaged relationship where you recognize their job is to protect people and keep the building safe. And so if you can reflect back that that is also your intention and that you want to help them achieve their goal in that, that's bringing them into the conversation early so they're not shocked, so you're not trying to like slip anything past them, that you're being really transparent about your understanding and acknowledgement of the risk. And it usually means doing some additional homework and being able to provide product documentation that validates, yes, this is structurally sound. Yes, this is good approved for fire. Yes, it's all these durability considerations that I know you're really concerned about. There's a bunch of pre-existing conditions I'd say precedent for pretty much any material I'm expecting you to be looking for that goes a long way. If code officials can see that other jurisdictions have approved them and have satisfied others' requirements for precedent, then
that can go a long way for certain officials. Even straw has is in the IRC. It's got an appendix in the IRC covering straw construction. Same with straw clay. Now there's cob and earth construction showing up in the IRC as well. So just any of those bits of data and research and quantified risk analysis, ASTM fire test ratings, so on and so forth, that you can kind of bring together and show that, hey, this is real, we've done our homework, people have looked at this, this is valid, here it is in the marketplace in multiple different locations, here are multiple different manufacturers are producing these things. All of that helps the fear of the unknown, which is the biggest risk that the code official is having to manage. Like, I don't know what the risk is that this is gonna provide to the market. I need to protect around that unknown. So a lot of it is just education, transparency, open communication, and maybe cookies.
All right, I'm going to Ian, hand up.
Hey, Jacob, thank you so much for your time. This is Ian. I'm
Hi.
with 475 in
Oh,
Oregon.
nice.
I serve Washington, so
Awesome.
I'm
Nice to meet you.
very familiar with embodied energy with respect to insulation, stuff like that. Something I'm less familiar with is like drywall. So if someone
yeah.
was looking for a particular type of drywall that had the least impact, would that be found using the EPDs or yeah, okay. So essentially want to look for what the local place is carrying. And
so yeah, it's a great question. There's a couple of ways to get into figuring out, so like, what's the better drywall? Beam has a bunch of product specific selections in there. So USG has a eco, oh gosh, I should know the eco board, eco rock, eco something. It's a 5/8 inch type X product that is like something, don't quote me, I know I'm being recorded here, but it's approximately, roughly approximately 20% lower than like average, sort of industry average. Looks, smells, feels, tastes, codes exactly like type X. So that's one of those great examples. Now to find that, Beam has that listed out separately, so you can see that there. I'm gonna also call out another fabulous tool, EC3, which is another free tool that Building Transparency put out. That's more designed for like commercial scale construction. The products are more commercial scale. The sort of the inputs and the user interface is much more for like construction managers and your average residential builder, but they've got a great database as well, and really nice. And theirs is more of a searchable database as opposed to a comparative listing like Beam is formatted. So you could do a search for drywall and look through their EPD sort of database and figure out, hey, what are some of the products out there? I would plan on going to your local building supply store with the product that you're looking for and documentation, and not expect that their sales team is going to be fully literate and ready to answer those questions. It will be awesome when we get to the point that the sales side of our industry has their own internalized knowledge around this and around their products. But my guess is we're still at the phase in this work where all of us are the primary advocates by bringing market demand to our trade partners, to our vendors. That's why I'm psyched to see a vendor, and 475 particularly being a real champion of this stuff, showing up, because it's not going to necessarily be coming from the sales force down. It's going to be coming from those of us that are consuming these products, knowing that, hey, we have a demand around a better product because, you know, we're accountable to it, and really making that visible to the people that are supporting us with material supplies and letting them know that there's a demand for that.
awesome. Thank you.
Yeah, thank you.
All right. Brent, take us home.
All right, so this was actually really interesting to me because I spent a lot of time on a cattle farm in Georgia, and my uncle grew a lot of hay, and we would save that hay and use it to feed the cattle.
Yep.
So does that hay that you're using and growing, is that similar to the same kind of hay that is grown for cows?
Great question. I love it. Similar but different. So when I think hay, I think of a amalgam or a composition of multiple different species that is used primarily for fodder. So it includes all the seed heads. And it's probably, a combination of like legumes and grasses, maybe some clover and some vetch, some alfalfa, what have you. And it's all bundled together with all of that nitrogenous, energy, nutrient dense seed heads. That's awesome for fodder, not so much for construction. So when we're talking about, I'm specifically using straw as the language around straw bale. Big difference between straw and hay is that straw are the tubular, almost entirely cellulose and lignin stalks of cereal grains. The nutritive heads have all been cut and turned into food. And what we're left with, the wheat and rice, I'd say, are the big two crops that we're predominantly using for construction. And so they're very monolithic, they're very uniform, both in their composition and in their structure. So we're really talking about cellulose and lignin in tubular stalks bundled into block form, as opposed to a multi-species mix that has a bunch of like seed heads and nitrogenous decomposable material. So the analogy with straw is actually most closely analogous to wood. So the tubular orientation of the grains and the chemical composition is very, very similar between straw and wood. And accordingly, its moisture profile is very, very similar in terms of the percent moisture content at which it will decompose or mold. And that's the really big difference. If there was a bunch of seed heads in there, the decomposition rate would probably be greater. And the sort of the matrix and combination of different forms and materials would yield a much lower insulative and probably less structural block as when you've got with straw.
Yeah, I mean, you answered another question I had about decomposition in this material being in the walls and the decomposition rate of the straw that you are using.
Yep.
What is the decomposition rate of that?
Yeah, great question. So when I hear decomposition rate, I'm thinking about like moisture content and time. And so say we start to see active decomposition at the high 20s to over 30% moisture contents above 50 degrees Fahrenheit for like a considerable period of time. And so to generalize that a bit, we see wood and straw behave really, really similarly in that they can both handle a really large amount of moisture for a relatively short period of time. They can handle a moderate amount of moisture for a long period of time. What they can't handle is a lot of water for a long period of time. So for some just anecdotal case studies, we've been putting moisture sensors and coming back and probe testing straw bale walls in our region for the last 30 years. I'd say pretty uniformly, actually, including my building, I just finally got around to testing the moisture sensors that I put in my walls 23 years ago. And the highest reading I was getting was around 14%. And this was during a melt period. So kind of like the worst possible scenario for all of the frozen condensate on the exterior plane of the wall to melt and saturate the outer portions of the bale. I generally see buildings over 10 years stabilizing at like an average around 10% moisture content in our region, in like the cold, frozen, sort of wet Northeast. There are bale buildings in North America that are over 100 years old. At my general adage, I've done in situ testing of a number of projects where the adjoining plaster or cladding has been fully saturated and the bales themselves have only been around 15-16% moisture content. So there's a lot of factors that go in. Basically, a lot of things really have to go wrong to get to rot conditions for straw, similarly to wood. Having been a retrofit contractor since 2012 or so, it never ceases to amaze me of how resilient wood can be and like how much really needs to go wrong for it to actively rot. And a lot of things can go wrong, so don't get me wrong, I see it all the time. But it's a resilient material. I consider straw to be very comparable in its performance that way.
Oh, man.
Yeah. So I'm gonna, Brent, is it gonna be quick?
Sorry, I was just gonna say, do you treat the straw? Is there any type of treatment to it?
We do not. Nope. So we're really using the straw that we use for construction is pretty much coming directly off the farm. We purchase wholesale from a network of organic farms in the Northeast. Get it right from the farm, and pack it in very high density form into panels. Primarily, initially we were building directly into walls. Now we're building them into panels for offsite construction.
Thank you very much. Thank you very
Yeah.
much for answering my
Thanks for the questions. Yeah, I appreciate it.
Jacob, just to wrap up, we're going to
Yeah.
get your slides from you. I know
Yes.
one thing we didn't quite capture was they are one-to-one substitutions that are available, but we also, a lot of times builders are like, well, what does it cost to do those substitutions? Do you have any graphics you can include in those slides that will provide some of those cost perspectives? I think I saw them in some of the studies.
Yeah, let me get with Chris and see what we have that's easily preparable. Yep. The things I can say really quickly anecdotally is some of the like SCM and concrete improvements just within the mix. I consider those to be essentially cost neutral. See some variability there, but generally, if there is a cost premium, it tends to be very, very limited. I consider cellulose, the switch to cellulose, to be cost neutral once we find a contractor that can deliver as such. I've definitely seen hyperinflated cellulose values for contractors that essentially don't want to install it or aren't very good at it, and so it takes them a really long time. But it does not have to be a cost premium. Any of the bat substitutions, I consider those to be more or less at cost parity. Some of those, like some of the hemp bats, are still a little more expensive. Some of the wood fiber products are coming down to be cost neutral. I'd say similar with the XPS and EPS board substitutions and the HFO to HFC foam substitutions. All of those are pretty much within like a margin of error of being cost neutral on a material basis without any impact on installation cost. But I'll see if I can get something visually data driven to help pack that into the deck. I'll see if there's something we've got kind of ready to go for that.
Yeah, and I know for finished products like bamboo and cork related kind of flooring products are relatively cost neutral when you're comparing them to either vinyl or hardwoods. And so there's, in some of those finished materials, there's a lot of things that you can get a waterproof cork vinyl alternative product out there now that is, ideally replaceable for anyone who has to have that like waterproof vinyl kind of feel.
Yeah.
So there are definitely vendors out here, like we said in our slides earlier, that can help people navigate those choices. Chris with Sedeco is actually on this call right now.
Oh, nice.
So, and some others we had on. So thank you, everyone. We will be following up within about a week with all of these great resources we talked about, as well as a link to the recording. And thank you for your time today.
Thanks for being here, everyone. It was a pleasure.
Thank you.